Okay, so today we're going to talk just basic review skills of stuff that we need to review from previous years. And you know how I was just talking about those duotangs I gave you there with just practice questions? If you can identify, oh my goodness, I don't remember how to factor to save my life, find a page on factoring and do some practice. Okay, like that's what they're designed for, is to help you target your weaknesses, because it's kind of assumed that everything we've learned up till now you still know how to do. That's what makes math so hard. So I want to do some examples with solving fractions. This one's just a basic FOIL it to death kind of question. How to deal with a square root. How to deal with a system of equations. And then another fraction one. So let's give this one a try. Any thoughts on how to start? Do you remember my analogy last year from Pirates of the Caribbean? Wait for the opportune moment. Do you guys remember talking about this? So in a lot of these scenarios, yeah. Sorry. You need to apply the rule for fractions, but you have to wait until the right time. What's the rule for fractions? What's like the key to it to try to get rid of your fractions? Cross multiply. You guys recall that at all? We're going to need to cross multiply at some point, right? The bottom of this fraction right here and the bottom of that fraction right there. There's a fraction there, right? It's not written as so, but there's a fraction there. We will need to cross multiply at some point, right? What makes math challenging is we have to do all these rules like in the right sort of sequence. So I gave an analogy last year of untying a knot. If you recall this. There's a huge knot right here. This is a big mess. So we need to get rid of the mess first by distributing. So let me know if I lose you here. If I were to distribute like this stuff right here and FOIL, you'd have 6x squared, 4x, minus 9x, and minus 6. Is it able to follow that? If not, please don't hesitate to let me know. I can slow it down. I'll do this in colors. That's the stuff in purple basically being FOILed out. Make sense? And then you get your x plus 2 on the bottom. Now is not the opportune moment. We should not cross multiply yet. We'll get there, right? But that's the key to math, is knowing what to do and when. Okay. Over here, I also have some more distributing to do, and I actually have two sets of it. I have to do the 7 by the 2, so that's 14, and the 7 by the x, or 7x. But we also have to distribute like the negative sign across the other two terms here. So you have to make it negative x and negative 1. So far, so good? And just so that in my mind, I keep reminding myself that we will be cross-multiplying, I'm going to throw a 1 on the bottom, because really, we do have a fraction equals a fraction scenario. I still don't think now is quite the right time to cross-multiply. We can, but what can we do before I get to that? Combine. Okay, you guys remember the phrase, combine like terms, right? So let's put together stuff that can go together. So over here, we could have 6x squared plus, actually not plus, that would be minus 5x. Minus 5x minus 6. Still over x plus 2. And then over here, you're going to have 6x and 13. Remember that knot analogy? When we started, this thing was a huge unruly mess of crap on the top there, right? But now, it's not so bad. I mean, it's not fantastic, but it's at least it's not got brackets everywhere, right? Now's the opportune moment, right? Now's the time to cross multiply. So let's take the x plus 2 and cross multiply it up here. And let's take the 1 and cross multiply it up there. So over here, you'll still have your 6x squared minus 5x minus 6, because that isn't doing anything. What happens when you take the x plus 2 and times it up by the 6x plus 13? What are you really doing? Devin back. Devin was always the person who said something. What do you do when you take this x plus 2 and you bring it up over here? Yeah, like FOIL it. Right? So I'll just like write it here temporarily. We need to FOIL that bit. So you're going to get 6x squared 13x, 12x, and 26. You guys in agreement on that one? Okay, we've now untangled the rope entirely. It's no longer got any major issues, right? Major issues would include things like fractions, square roots. I mean, when we get to them, exponents and logarithms and stuff like that. But right now, there's no major issues anymore, right? So the last step is now we just need to solve it. You guys notice that there's 6x squared on both sides? That's nice.
Does it say plus 13x plus 12x?
Yeah, because I have 13x times by x right there for the 13x.
Yeah.
And then when I did the 6x by the 2, that would be the 12x.
How come you don't add this?
Oh, I'm going to actually. Did you add them together already?
I would know how.
You can, yeah, I'm going to. Because the last step now is let's combine some like terms. All right. So let's put these guys together and make it like, say, 25x. Is that kind of what you're referring to? Ian?
Yeah, I just didn't know why you did that.
Yeah, I will. I just haven't got to that step. But good call. So let's put those together and make it 25x. And then this one's gone here, and this one's gone here. So let's put all of our...
Shaylin, please come to the office for checkout. Shaylin Atachek, please come to the office for checkout.
Let's put all our x's on one side. So why don't we subtract 25x to both sides and make it minus 30x over here. Let's add 6 to both sides. Make it 32 over here. Divide both sides by minus 30. Is it follow that? We're actually not done. This is one of the things that you're going to find most frustrating about math is that we actually have to use like a junior high skill still to actually finish the question. It's actually 16 over negative 15. You guys see that? Because I haven't reduced it. On the diploma, they are nasty about this. They'll make these a numeric response question, and then when you type in your numeric response question, you probably would, on your answer sheet, put in 3230. But the answer would actually be 1615. You guys get what I'm saying here? So that's what makes the math diploma probably, in my opinion, one of the hardest ones that there is just due to all the little things that you can't forget from previous years. So don't leave it as this. Leave it as 16 over like 15 with the negative. So if this were a diploma, they might have you you get like the 4 bubble spaces. It could be 1615, and it wouldn't be 3230. That jogging memories on doing some stuff from last year? It's trying to look.
I have a question.
Yeah,
Do
go
you
for it.
always leave it in a fraction, or will you ever have to actually solve it? Or will the question
It'll tell you on the diploma for sure, but I would say in most of my experience, they're looking for it to be like left with a fraction. It's almost never a decimal, but once in a while. But that's the thing, is that they're gonna expect that you know how to convert fractions to decimals, which is kind of silly because that's actually like a grade 5 or 6 kind of thing, right? But you still have to be able to do it. And so it's so frustrating to be the teacher especially and see your kids know how to solve a question. They know how to do the grade 12 stuff, but they get it wrong because they forget to do something that's like, way back in the day. You know what I mean? So. Well, let's try this one. Alright, so if you think of my rope knot analogy thing here, it needs to be untangled first. Right? This is kind of a mess. There's no major issues like square roots or fractions, but it still is a mess in terms of needing to get distributed, so let's FOIL this thing out, right? 3x squared plus 9x minus 5x minus 15 on one side. You guys are okay handling that? Stop me if I lose you, right? Depends on your strategy for how to deal with this side right here. My personal strategy, I'm going to hold off on the 3 until I'm done, and then I'll triple it. That's my personal strategy. You can do it whichever way you like. But I would do this. I'd go x times x 2x, which would give me 2x squared. Now that I have 2x squared in my head, I'll then make it 6x squared. That one will give me positive 5. I'll put that one at the end. Positive 5. I'm going to have to times it by 3, so I'll need a positive 15. This one will give me negative 10x. Times by 3, it'll be negative 30x. That'll give me negative 1x. Times by 3, negative 3x. If you have another method of distributing that out, I don't really care. I mean, whatever works for you. But hopefully you have something similar to this when you're done. And maybe you put the 30 and the 3 together and made it a 33. Let's do that actually. I just cross this out real quick here and make it a minus 33x. And over here, let's do the same thing here. Let's make that a 4x. What kind of polynomial is this? Terminology? Is it linear or quadratic? Yeah. Do you remember the difference why compared to the last question? Linear only has x's by the time you're done, whereas quadratic will have x squareds. Okay. Tomorrow and moving forward, we're going to have to learn how to do with the x to the 3s, 4s, and 5s. But for right now, this is still older news, so this is quadratic. So to solve a quadratic, you need to make one side equal to 0, and then either factor or use the quadratic formula. So let's start by putting everything on one side though. So if I drag everything, say, this direction here, you would have 3x squared minus 37x plus 30. Make sense? I don't want to factor this because that sucks. We could try, but let's use the quadratic formula. You guys have your formula sheets there by there? Guess what? It's the first thing on there. In my recent experience, they've always been putting at least one quadratic formula question on the diploma, or at least it involves the quadratic formula. So probably like the question will involve doing some cubics and quartics, something higher level, but as part of solving that, you'll have to use the quadratic formula. You know what I'm saying here, where you can't forget what you learned last year though? So here's the formula. Negative b, so if I take a negative 37, it's just positive 37. Square root of b squared minus 4ac all over 2a. Do you guys recall what the square root tells us about the answers? What if the square root is positive? How many answers are there? What if the square root is negative? There are no answers. And if the square root somehow ends up being 0, there's one answer. So usually what I do is I work on the stuff under the square root sign. It has a name, it's called a discriminant. So negative 37 squared minus 4 times 3 times 30 gives me 1009. Do that as well. So just the discriminant part I have as being 1009. Well, those are answers. I know it looks strange, but there are 2 answers hidden in there. Emily, you asked me a little while ago about whether they'll ask you, like, say, a decimal number. On the diploma in recent years, when this has been an answer, now it hasn't been like this. Usually it'll fit the form more like 7 plus or minus root 5 over 2. They usually then make it be like an A, B, C scenario, where you'd say like it's 7, 5, and 2, and you have to like kind of take one from each location, if that makes sense. So I've never seen them actually ask for the decimal number value. It's usually the exact values. So This one, obviously, you couldn't type into a formula sheet because there's way too many digits. You guys recall doing this? Alright. Alright. Pen does work. Alright, so there's our final answer. Alright, next one. What's the twist to this one? What's our problem that we have to wait for the opportune moment for? Gotta get rid of the square root, right? So before we talk about when the opportune moment is, what is the key to getting rid of the square root? Square both sides, yeah. The opportune moment then occurs when you get the square root all by itself. As long as the square root is by itself, you're good to go. Hypothetically, let's say that this plus 2 was over there. Not ready yet, right? Bring the 2 back to the other side, and then you're good to go. So this particular question right here is actually already at the perfect moment of 2 prime. Square both sides. Square this side. Square this side. When you square your right-hand side over here, you get 5 with the x plus 2 left over. What happens when you square the other side over here? Does it give you x squared plus 4? I'm actually hinting that it doesn't. Why is this bit right here not x squared plus 4? It's x squared plus 4, x plus 4. What do we miss? This x plus 2 squared really means take x plus 2 and literally write it next to itself. And when you FOIL it out, sure, x times x is x squared, right? And 2 times 2 is 4. But you've missed this guy right here giving you a 2x. And you've missed this guy right here giving you another 2x. So make sure you don't miss those middle terms. Yeah.
Could you divide out a 2x from both sides?
Yeah, you can actually. I'm not going to do that though because I want to make a point. But you do actually see something clever. So. This one's designed to remind you about a scenario you might have seen before. This is going to be x squared plus 4x plus 4. I'm going to distribute this side out though. So even though Jessica, you're right, I could have done some canceling. If I distribute it out, it should give me a 5x plus 10. And now we've untangled our rope, right? The knot is untangled, we're good to go. All we have to do is solve based on what sort of form it is. So up till now, you guys know linear and quadratic. If it's linear, just get x by itself. If it's quadratic, make it equal to 0 and use the quadratic formula or something. So let's bring, say, this stuff that way. That's the worst arrow I've ever drawn. And make it x squared minus x minus 6 equals 0. That makes sense? Okay, now you could use the quadratic formula here. Or you guys could call it a factor. Mini lesson on factoring, you're looking for numbers that add to give the middle number of -1 and multiply to give the outside number of -6. Sometimes I would write it out like this. This plus this is -1. This times this is -6. You guys recall doing this? You just have practice, right? Because you don't do it regularly. The numbers are -3 and +2. So you can just take this directly to x minus 3, x plus 2. So what are my answers? Yeah. Quick recap of terminology. These guys right here, we call these things roots. These guys right here, we call them factors. Remember like when we did graphing stuff, if you had a quadratic graph, if this guy right here was an x-intercept or a root of 3, it meant that the factor for it was x minus 3. And over here, if you had a root or an x-intercept of -2, it meant the factor was x plus 2. You guys recall that? So there's 2 x's. Except, I'm hoping this is the case, because you know how you thought we could cancel something out? There might be something funky about this one when we actually check our work. So we should always check our work. If I throw in, let's just see how this works here. throw in the value of -2, for example. -2 goes right there. Then this side would be 0, right? If I put in -2 right here, then this would be 0, and then 5 times 0 would be 0. So it looks like -2 probably works. But I'm hoping, I think I designed this one. And I hope I did. Let's try 3. 3, 3. 3 plus 2 would give you 5. No, this one isn't going to cause a problem. 5 times, that's 5, right? We'll give you 25. When you square root 25, it'll give you 5. There actually were 2 answers there. I thought, the reason why I didn't let you do that thing there, you guys remember the word extraneous? An extraneous solution is where you get an answer and you check your work and it doesn't work still. For some reason I thought this one was going to give us an extraneous one, but it looks like they both work. So when you thought back here that we should leave this as x plus 2 squared, was that your thought there? And then you could cancel like one of those x plus 2's, you could cancel with that one? Is that what you were kind of going for? So I'll leave you with x plus 2 equals 5 minus 2 minus 2 means x will give you 3, which is what we had. Sometimes when you divide and cancel something out like that, it actually removes an answer that could have worked. Because minus 2 clearly seems to work, doesn't it? I don't see any flaw with minus 2. Minus 2 plus 2 would give you 0, yeah. And then minus 2 plus 2 would give you 0. Times 0 by 5, it's still 0. Square root 0. Yeah, this both should work. Okay. So actually maybe it was good advice that we didn't do what you suggested there. Because sometimes when you divide something away, you're actually eliminating a possible answer. Anyways, do you guys recall doing stuff like this? And do you recall extraneous? Even though this wasn't extraneous, the idea behind it? Okay. Because there's way more extraneous things in grade 12. Okay, another one. You need to know how to do something called a system of equations. System of equations is where I give you more than one equation and more than one variable, and you're solving for x and for y. Essentially, a system of equations is like where you have like a graph and you have another graph, and I'm asking you where do they intersect? Does that make sense? And you're looking for like x, y coordinate pairs. The main methods people use to solve these algebraically are substitution and elimination. You guys remember those words? So, those are other skills I need you to recall. I would try myself on this one here, substitution. Because right here, I think it's very easy to get y by itself. If I bring the 10 over here and make it 5x minus 10, and I bring the y over here and make it positive y, I've now isolated for y as an independent variable by itself. And then I can take the remaining little bit right here and substitute it in for that y over there. You remember this? Okay, let me know if I lose you. So now I'm going to write x squared plus x minus 2, but rather than writing in y, I'm going to write in 5x minus 10. This is a slight knot in the rope. It's not a huge one, right? It's not massive, but I still have to undo it, right? So you're going to have x squared plus x minus 10x plus 20 equals 0. Combine like terms, x squared minus 9x plus 20 equals 0. Quadratic, linear, quadratic. You can use the quadratic formula if you have to, but can you guys see how to factor this without doing a lot of review on it? What does it factor to?
Minus 4 and minus 5.
Yeah, 4 and 5, right? Both of them negative. So that means that if the factors are minus 4 and minus 5, the solutions or the roots are 4 and 5. So you get 2 answers. But we still have to find out what y is equal to as well. So we actually still have to go back to y and go back up here and see what happens when we put either 4 or 5 up here. So I'll just do some mental math here. 5 times 4 would be 20 minus 10 would be 10, I believe. And then 5 times 5 would be 25, minus 10 would give you 15. We have x's and y's available now. You recall this? When did we do math? First semester last year? Wow. Do you guys feel rusty? Okay. Use those practice journals and do a little bit every day. Okay. Like the idea would be spend 5 to 10 minutes at the beginning of class or during advisor period or whenever, right? And just find something in there that you recognize that you go, okay, yeah, I know I've done this before, but that you know you're rusty on, because we got to knock the rust off these skills in order to move forward, right? Okay, this is the last one, right? All right. So, opportune moment. What are we trying to accomplish here? What do we need to do in order to solve it at some point? We need to cross multiply. We're not at that point yet, right? What is the requirements to effectively cross multiply? You guys remember? You have to have a fraction on one side and a fraction on the other side, but like single fraction. You have to have fraction equals fraction. Okay. So this side right here has a bit of an issue. So I need to remove this side over here and like put these together as one big fraction. Before I do that though, I need common denominators. And before I even get to common denominators, I should do some factoring here and say, well, this is really a difference of squares. This is x plus 2x minus 2. You recognize that? And this guy right here is 6 bracket x plus 2. Yeah, I'm doing here, I'm just removing this and removing this and doing some factoring. Do they have common denominators? Not entirely common. Is there some stuff in common though? Yeah, the x plus 2 is in common, right? So what that means is we're going to have to times this guy by 6 over 6 so that they now both have 6's on them. And we'll have to times this one by x minus 2 over x minus 2, so those ones both have x minus 2's on them. So hopefully you guys can follow because it's going to be a little bit of a mess here. 6 times 2 on the top will give you 12. This 10 is going to distribute into both of these and give you 10x minus 20. And the bottom is going to be just one big denominator of 6. X plus 2, x minus 2. Did I lose anybody? One more thing, and sometimes I'm just going to erase and write over top just because it's easier. Up here, there's a couple of like terms I can put together. I may as well take the 12 and the minus 20 and put them together and make it like a minus 8. And just go right to that step. Now, do we have fraction equals fraction? Yeah. Now we do. So now we can cross multiply. I'm going to take the x minus 2 and times it up here. I'm going to take this whole mess down here and times it up there. So let me write it out one more steps before I do all my distributing, because there's going to be a lot of distributing here. Still good. Okay, distributing time. We're back to having a knot in the rope. It's a mess again, right? So FOIL it out. This is going to give you 10x squared minus 8x minus 20x plus 16. And on this side over here, this was a difference of squares. Now this was x squared minus 4. I just need to times it all by 6. So let's make it 6x squared minus 24. You can kind of follow my little, I'm trying to save some time here. Linear or quadratic? Will the x squareds cancel or not? They won't, so we have to use a quadratic solving method. So let's throw everything on one side. Let's make it 10x squared. Oh, hang on, no, I gotta subtract the 6x squared. So if I take 10x squared and I subtract the 6x squared, there should be 4x squareds left over. These guys right here are going to give you minus 28x. And then when I add 24 back to this side, that'll give me plus 40. You remember doing this last year? And how, like, it was like, you know, pages upon pages of work? Yeah. Bringing back good times? That was the first time I worked with you guys. You guys never said anything back then. Remember that? It's like you were scared of me or something. Okay, any thoughts as to what to do next? You can use the quadratic formula, but I got a better idea. Yes, there's a 4 in all of these. Now I'm not going to divide by 4, I'm going to factor 4. Yeah, factor 4. If I factor out a 4, it leaves you with x squared minus, what is that, 7x plus 10 equals 0. Now it doesn't look so bad, because there's got to be some numbers that break up into the 7-10 combo, right? Is that order? That'll work, yeah. Both negative, go with 5s and 2s. Again, order doesn't really matter on this one. These are factors. I want to make sure I use that terminology because it's going to come up a lot in our next section here. Those are factors. There are 3 factors. One factor is 4, so number 4. Another factor is x minus 5. Another factor is x minus 2, which means our solutions or roots are going to be 2 and 5. I now know why I put this question here. Go back up to the top. One's extraneous. Which one? Why is 2 not going to work?
Because it'll be 2 divided by 0.
Yeah, like right here, or right here, really. Any of these ones causes a problem, right? Because 2 squared gives you 4. 4 minus 4 gives you a 0. Can't do that. Or right here, 2 minus 2 gives you a 0. You can't work with that. So, I should check 5 just, you know, to make sure that it does work. So you're going to have to be super careful if you use your calculator with brackets here. So it would be 2 divided by bracket 5 squared minus 4. Close bracket. That's the first fraction. And then I would add 10 divided by new bracket 6 times 5 plus 12. There's what I get on the left-hand side. On the right-hand side, it's 1 divided by bracket 5 minus 2. Yeah, both sides are equal. That was like 2 months last year, right? All that stuff, right? Like it was the first step we did, and it was pretty hard at the time. Does it seem a little bit easier now that it's? I mean, I know it's been a year and a half. You ever trying to do it though? Kind of. Okay. Well, that's all I got today for notes. So why don't I pause the video recording, and then we'll talk about where we want to go from here.
So just